So we are going to first start with a review of 7.4. 7.4 was about simplifying. The first thing we talked about in 7.4 was simplifying expressions using the product property. Remember that the word product means multiply. So in this first example, you want to think of 72 as two numbers being multiplied together, as well as your m's as two numbers being multiplied together. So 72 would be 36 and 2. M to the 7 you'd want to think of as M6 and M. That creates for you two perfect squares in the front, and a set of perfect squares can be simplified. So 36 and M6 are perfect squares. So the square root of 36 is 6. M to the 6, you take your power, divide it by 2. So you get M cubed. And then the non-perfect squares will remain inside, and you get 2M. We want to do something very similar in example B. So you want to break the number up into a perfect and a non-perfect. If the power is odd, you're going to break it up into the even one less. And then if it's a perfect square, you're going to just leave it as is. So 50 would become 25 and 2. A to the 5th is going to become A4 and A, thus allowing you to leave the non-perfect squares inside the radical and bring the perfect squares out as their square roots. So then we moved on and we talked about the quotient property. The quotient property is a fancy way of talking about division. So the word quotient means to divide. So you can take division and think of it as the top divided by the bottom separately. So d to the 12th is nice. You divide 12 by 2 and you get 6. N to the 9th is not as nice. It's kind of like N8 and N, which means we're going to have to rationalize the denominator. So you get d to the 6th over n to the 4th root n. But we cannot have a square root or a radical in our denominator. So we have to rationalize by multiplying by the square root of n over the square root of n, because that's like multiplying by 1. Anytime you have the same square root times itself, it becomes itself. So you get d to the 6th square root n. And then that would be like n to the 4th times n. And remember that if you have the same variable times itself, you add your exponents. So d6 root n over n5. And again, you may not need every step. I am showing many, many lines of work. Some of you may be able to do that simplifying in your head, etc. So the difference between A and B is the power on the radical. This is a square root. It has the imaginary 2. This is a cube root. A cube root is different than a square root in that you need 3 to simplify. So this is like the cube root of 9 over the cube root of 2m. So in order to rationalize this, we need 2 more cube roots of 2m. Because now I need 3 of each. So for a square root, you need 2. For a cube root, you need 3. So that becomes the cube root of 9 times 2 times 2 times m, which we're going to clean up. And when you have 3, the cube root goes away. 2 times 2 is 4. 4 times 9 is 36. M times m is m squared. This 36 and 2 and that m squared and m cannot simplify because this is in the cube root and this is not. Then we moved on and we started talking about multiplying radicals. So our strategy for multiplying was to multiply the outside numbers together. So 2 times 5 was 10. And then to multiply the inside numbers together. So when we multiply our inside numbers together, we're going to multiply 18 by 72. A3 times A2, so you're going to add those exponents, and then you have B3. You're always going to just check to see if the number you're looking at or is inside is a perfect square. So in this case, 1296 is a perfect square. It is 36. So this becomes 10 times 36. A to the 5th we already did on the front. It's a squared, and an a stays behind. B cubed becomes b, and a b stays behind, because a5 is really like a4 and a, and b3 is really like b2 and b. So also you're going to do is multiply 36 by 10. So you get 360 a squared b square root ab. In order to add and subtract, they must be the same number under the same radical. If a radical can be simplified, you need to simplify it. So all 3 of those numbers simplify. 18 is 9 and 2. 50 is 25 and 2. And 98 is 49 and 2, thus creating perfect squares within each. So square root of 9 is 3. 3 times -4 is -12. Square root of 25 is 5. Square root of 49 is 7. Now all of the values under the radical are the same. So we're going to do -12 plus 25 plus and we got negative 1 square roots of 2. And then the last part was foiling. So you have to do first outer. And remember that when you FOIL, you multiply the inside radical terms together and the outside numbers together. Inner and last. If the inside radical can be simplified, you would want to do so. So in this case, the square root of 49 is 7. 7 times 3 is negative 21. The other values do not simplify, therefore we leave them as is. So that is a wrap up